So in this video, I want to talk quickly about the process that I used to strip the MI PC board down to the blank board. We're looking at a photo here of the board, pretty much as I received. You can see all the dust and dirt on it. It was just really nasty. In a previous video, we've removed the ICs from the sockets. We've removed these potentiometers and talked a little bit about potentially stripping the board down further. So there's kind of the state it came to me. I spent the time to unsolder all of the components off the board. I did finally remove the pin connector here on the edge as well. Sockets came out really easily overall. They weren't bad to remove. It was a little bit rougher working with some of the discrete components, and I had to come back and do some cleanup to get all the vias open. You can see here that these vias here have solder in them still. There was a bunch that do, these two here, etc. So I did have to make a pass through the board. But again, just look at the amount of dirt that was underneath these components. There was no easy way to wash this off. So once I got the board stripped all the way down, well, down to this point, I washed it. And this was just warm water, warm soapy water, a scrub brush, nothing fancy, and just gave the board several good scrubs and rinses with warm soapy water, and we got it to this state, so all that dust is gone. The board looks much better here. There's of course bits of the black silk screen missing. There was a sticker down here, if you remember, some kind of sticker that probably said property of whatever. But again, it just turned out pretty well. I did, like I said a minute ago, remove this connector and cleaned out the vias that actually had solder on them. I can see one there, one there, one there, which resulted in this here. So we're looking at the back of the printed circuit board here, obviously. And I think this is with all the vias finally cleaned out. This was taken on a flatbed scanner, so it was after I had considered that work done. Although looking at it, I'm not totally convinced they're all open, but it's pretty damn close. So you can see the back of the board turned out really well. I didn't damage the board anywhere, luckily, which was really nice. The back cleaned up really well here as well. I apologize again for not having the video of the process. The video is just, it's unusable. I just used my FR300, my Heiko FR300, the soldering tool. I had to strip the tool down and clean the solder collection area multiple times during this. My process was to go in and add fresh solder to all the joints I wanted to open up, and then vacuum them off with the tool. So it did remove a lot of solder. I ended up replacing the filter element once and cleaning it multiple times, and cleaning it included taking cotton swabs and alcohol to clean the inside of the solder collection area out, get good airflow through it again. And once the tool started to sound different, where it was having a harder time pulling vacuum, I had to clean it again, or it just didn't perform. Keep the tool clean. I've mentioned this before. So you can see, this stripped down really well. I'm really happy with this. And if we flip around to the front here, you can see what we've ended up with on the front. It's, again, this is the scanner on my flatbed scanner. It is nice and clean. It's turned out really well. There's a little bit of something green down there. I'm not sure what that is. A bit of corrosion maybe from something. These sockets weren't stuffed. So, I removed these 240 pin sockets, the bottom 8 sockets here, all of the sockets here, the 216 pin sockets here, and then all the discrete components. As you can see here, we'll zoom in on this a bit, just because the board is really nice overall. 1K ohm, 1%, 1K ohm. This is where those 4 resistors were stacked kind of on top of each other, soldered in oddly. Actually, it was like a via that's not open there. But you can see it's marked well. 20K 10 turn pot goes here. There's a Mylar 0.01, Mylar 0.01, 3.3 microfarad 16 volt electrolytic, and there's the plus. They've done a really good job with the silkscreen on this. I was really impressed when I first noticed they'd done this, and then getting the components off. 0.01 microfarad 50 volt disc cap, for decoupling. It's interesting that these are marked and these actually aren't. But again, they're the same thing. These are just decoupling caps. Just really, really happy with how this has turned out. I scanned this at 600 DPI. That's why we're able to zoom in here and actually still have good resolution. So there's a 1N751 diode here. There's a little mark for the direction the diode goes in. Just really happy. 0.0 150 volt cap, 300 ohm, 5%, 0.05 mylar. I mean, they've just done a really nice job with the silkscreen. And that was really part of when I decided to strip the board all the way down that I was excited about was, we can see all the silkscreen markings. Get some really nice photos of the board. I really need to look at this very close. I don't believe I damaged anything. Most of the stuff came off really well. There's a little bit of, like right there, that's kind of an odd looking. Oh, is that just dirty silkscreen? I think that's just dirty silkscreen. Interesting. Those two 6-pin odd connectors came off really easily. I was surprised. This threw me right here that there actually is a link between those two pins. I've never had a lot of luck removing these right angle pin connectors. This was right angle, goes to the ribbon cable. This was a pain. I ended up cutting this connector up into little pieces to remove it. So the original connector is long gone. There was just no way to get it to pull off the board in one piece. I've never had one successfully come off in one piece. So it was cut up in little segments of 4 pins, and then those were manipulated and removed. And again, it looks like I didn't damage anything. I've obviously scratched there because you can see some fresh copper. I used some alcohol here and Q-tips. This is what this mark here is. It's just where I kind of spread flux around. The board will need a final cleaning. But happy with this. The logos turned out well. Just happy with how this turned out. I'm pleasantly surprised. Bunch of 1N914 diodes there. Just so pleasantly surprised that everything here is marked like this. Thank you whoever designed this board and laid out the silkscreen for the work you put into this, because it was obviously a lot of work. So I'm still looking at options to get this board captured. And basically, as close as we can get of a clone created so that people with an MMD-1 who would like to have the expansion board can get one, because I've never seen the expansion board itself on eBay all the years I've been watching E&L stuff. I see the MMDs ones a fair amount, and it's much rarer to see them with the card. So I feel like if I produced came up with a reproduction card, it would be useful to people. There's some minor changes I would make, such as probably the 8111 RAMs look to be impossible to find. I found some 2111s. They're a little spendy. It might be change this to a more common type of RAM. The UARTs are generally available, including new old stock. I haven't looked at the linear ICs yet. There was 4 of them here and 2 here, if I remember right. I have not looked to see if those are generally available. These 1702s are really difficult to program. You're not going to find a USB programmer that can program 1702s. They require voltages above 50 volts. So I might rework this to be like a 2716. But the 4 of these 1702s together is a 2716. The other thought would be to probably put in pin headers. have the footprints for these specialty connectors, but also put in just pin header connections so you could easily make it easier to get to these connections. I don't know, is anybody interested in something like that? Let me know in the comments if it's something you might consider, wanting for your MMD-1. Think of what else to talk to here. We'll see if I can, get a close layout, maybe with a few changes for more modern parts. This is all TTL, there's no problem with that. Say these were two, I don't even know anymore, analog devices, linear devices, I mean. I have to go back and look at the part numbers in the BOM. Anything else worth talking to here? I guess we can zoom in, or I'll kind of mention this. I'm guessing, I don't know if this board was hand taped. It's so hard to say. There's a full footprint here. It's got silkscreen on part of it for that pad, and then there's a trace coming off that runs in between these two up here. So it's a typical memory where you've got signals running in between pins. This run here is actually the width of what you see here in the silver that comes down and connects onto here. So the silkscreen isn't aligned super, or the solder mask isn't aligned super well here. It's good enough. I'm trying to determine if I think this was hand taped or not. Based on the gentleness of these curves, I tend to think hand taped. I have done a little bit of hand taping of boards in my career. You could buy, basically you do this, 2x or 4x larger than the board. You're working on a piece of clear plastic or vellum, and they used to be able to buy, basically rub on, like you can buy rub-on vinyl letters and rub-on those kind of things. You could buy pre-made pad layouts that were rub-on, and so you could buy this, this, what is it, 18-pin socket here. You could buy all that pre-made, and you can see here what was pre-made. There was a complete pin there, a line to go in between the two pins, and you just kind of line those up and rub them on, and then hand taped in the connections between them as needed. I see subtle differences in the position where it comes in the top of the pad, so I do think this was hand taped. Several things tend to say so. Be a little bit difficult, should be a lot difficult to reproduce these curved lines in like KiCad. I've watched some videos of Jerry Walker, who reproduces large PCBs. He did a ADM3 maybe terminal recently, reproduced a board. He goes in and he measures, the diameter of a curve, and he gets it down to where even the curves match the original board. Beautiful work. I appreciate it. I personally am not that, what's the term, obsessive. So just really pleased how this turned out. It's interesting that there was so much work going to get all the component values in place, but for the ICs, it doesn't say, AY5, whatever the UART is here, it doesn't say, 81 or 8111-4 RAMs down here. That is what it is. So anyhow, I've rambled on. I'll apologize again for losing the teardown video. It kind of is what it is. I've attempted to edit it, and it's just not anything I can edit and get anything useful out of. It's just a mess. So that's what this video is about. So we'll recap here. One quick look. Original board, dirty, nasty. All the components removed. It hasn't been cleaned yet. You can just see the sea of dust and dirt. And this was brushed. If you remember, this was brushed before I removed the components, and a lot of this came loose in the brushing. Then after being through a cleaning cycle, so anyhow, I probably already said this. I tend to do this a lot. I will wrap this one up here, and I will see you in the next video in the series here. I don't even know what that one's going to be yet. So, but I'll see you there.